We're going to do an overview of the combination circuits chapter here. And I kind of want you to take a look and see how short the actual chapter itself is. Because once you get after the first few pages, it's pretty much all just sample problems and them showing you how to solve stuff at that point. So while there's really not a whole lot of concepts we're adding, and the chapter itself is pretty short, you're going to see that actually putting it into practice is where it gets kind of difficult. So for day one, we're just going to kind of cover the basics of combination circuits, and we'll spend a couple more days getting deeper and deeper into it as we practice doing these. But let's go ahead and just cover some of the key points. So as far as the objectives go here at the top, you're going to want to make sure you can do all that at this point, especially for test purposes. So if you can define the combination circuit, list the rules of the series and parallel, and then solve the combination circuits using those rules, you should have almost absolutely no problem on the test, but it's a little bit easier said than done. So the first part it talks about here in 8-1 is tracing the current path. So as we look at some of these down here, like in this diagram, you can kind of see that the current is going to come up, it's going to be constant through here, then it's going to separate and then meet back up on the back side, and then over here it's going to be the same all the way back as it was up top. So with those ideas, we can kind of get an idea that none of our resistor formulas are going to work in and of themselves just across the map on this. We're not going to be able to have any resistance totals, voltage totals, or current totals that are going to be the same as any resistors at this point anymore, because they're all going to be bits and pieces of each other, and they're going to be kind of mixed together. Next point is nodes. So nodes are these little points here and here. Those are points where branches intersect. And right here, a junction point, such as this is often referred to as a node. So wherever you see a path where three or more parts of the circuit come together, that's going to be what this chapter refers to as a node. And because this circuit contains both series and parallel elements, that's why it's considered a combination. So if it has elements of both of them, that's considered a combination circuit. So again, not a whole lot we're adding to it here. These two right here are just things that we've already covered in other chapters, but it should be just second nature at this point. You should be doing enough of these problems to where you're not really having to remind yourself of these rules. You know how to solve a series, you know how to solve a parallel. If you don't have it down yet, make sure you memorize these areas here. Now, looking at this part right here, what we're saying is on the diagram here, or figure 8-2, it shows 4 different resistors. And we're going to talk a little bit more about that there, but just take a look at it here. You can kind of see that these two are in series and these two are in series. And then those two series sets are in parallel with each other. So we'll be able to do certain things with these two together, but we can't really do anything this direction with these two. And we'll be able to do the same thing by combining these two. And then once we have totals, we'll be able to combine them down there later. We'll get into that a little bit more. So if you look at the way they've written the resistance total here, it's the resistance total for the parallel formula, but RC they're calling is just a combination of adding 1 and 2 together and then adding 3 and 4 together. So they're kind of using that rule for series circuits where you can add the resistors together and then just combining those for the bottom value down here and then putting that into the parallel formula, which a little easier to actually visualize and maybe draw out the circuits than to try and plug these formulas inside of each other. So 8-3 is a simplified version of 8-2. So you see they've got 2 sets of resistors here. They've actually just added those values together to combine them to one set of parallel resistors. So that one set of parallel resistors doesn't really tell us anything by itself, but it gives us the ability to now combine these two using the parallel resistance formula that we know. So now that all we have is 2 resistors in parallel, if we plug that into our formula, all we have to do is this. So we're just plugging this value in and this value in here and here. Now again, these aren't real resistors, so these numbers, these values here don't really do a whole lot for us, but they do let us break the circuit down so we can start solving this stuff. So once we get to that point, you can see they've just plugged those values in here. And if you put that in our formula, this is the total. So the resistance total, 240 ohms, they're plugging in here. We had the voltage total, and from that, they've solved for the total current. So it's relatively easy for the first step to find the totals. Where it gets kind of hard is working backwards to find, up here at this point, the individual values for each resistor. So if we had all the totals here, we'd have to now go backwards and kind of use our rules for parallel and series circuits to find these values. And we can't really plug in any of those previous values because they were made up resistors that we made to kind of consolidate this stuff. So that's a pretty good overview of the chapter for the first day. I'll go a little bit deeper into it as we spend a few more days on combination circuits. But for right now, before we start trying to turn everything into complicated drawings like this for day one, let's just for the most part focus on finding the resistance totals. So if we can just simplify them and get this total, that's going to be kind of step one for almost all combination circuits. And then once we get comfortable turning something that looks complicated like this into something that's a little bit more basic, and then can get the resistance totals and get comfortable with that, then we'll start working them backwards from there and then finding values for every single resistor here along these paths. So for day one, again, just focus on finding the resistance totals. If you feel like I got a good handle on that, you can go ahead and start finding the values that we're missing in addition to that. And check in with us if you're still having trouble finding the resistance totals. All right, I'll check in with you guys again soon.